later. So before looking at this video, it would be really helpful if you've gone through and remember the reagents that are used to carry out elimination reactions and addition reactions, and also understand about Zaitchev's rule for elimination reactions and Markovnikov's rule for addition reactions. So what we want to do here is look at how we can do a sequence of organic reactions to produce the organic product we want. And in this case, what we have here is we have propane 1-ol, and I want to go and turn it into propane 2-ol. And what I can do is a sequence of elimination and addition reactions that will move where the substituent, the OH, is attached. In the start, the OH is attached to the carbon. So I'm going to add concentrated sulfuric acid. And if we remember that when we add that reagent, what it does is remove the OH and a hydrogen from an adjacent carbon. So it's going to remove these two substituents here. Well, a hydrogen isn't really identified as a substituent, but it's going to remove the hydrogen and the OH group, and it's going to produce this alkene here, prop 1-ene. Now, if I want to remember, I said that I wanted to turn it into prop 2-ene. I'm now going to have to carry out an addition reaction to add the OH back, but I want to add it to the second carbon. Now we're quite lucky because what happens here is when I add H2O, H+, then the majority of the time the hydrogen will add to the carbon with the most hydrogens already. That's the first carbon here. And the OH group will add to the carbon here with only one hydrogen after the double bond is broken. And that will form propane 2-ol. And the reason it does that, remember, is because this carbon can be said to be rich in hydrogens, and we have the general rule that we remember: the rich get richer. So this is the major product. So I can go through these two reactions, and when I do this, I have changed this molecule from propane 1-ol to propane 2-ol. Now, if I needed propane 2-ol for further organic reactions to make a specific molecule that I wanted, I could source it or make it from this propane 1-ol I originally had. So here's an example of the type of question you might have. Explain how you might convert 2-chlorobutane into 1-chlorobutane. Assume you're able to separate the minor product and the major product. Include a reaction scheme in your answer. So, well, I'm writing a reaction scheme, so let's write down the reagent, 2-chlorobutane. I want to turn it into 1-chlorobutane, so I'm going to have to turn it into an alkene for a start, right? And the alkene must have the double bond on the end in order to add the chlorine to the first carbon. So here, the first reaction is going to have to remove the chlorine and the hydrogen from the carbon off the first carbon. Now notice if I remove the chlorine here, okay, and we're going to do that by adding potassium hydroxide dissolved in alcohol. So I remove the chlorine. The reaction I want to happen is removing the hydrogen from the carbon that is adjacent, that has 3 hydrogens, not the carbon that has 2 hydrogens. So what I'm going to produce here is I need the minor product of this reaction. So here I've produced the but-1-ene, which is important because if I don't have but-1-ene, I can't make 1-chlorobutane because I can't add the chlorine to the first carbon. But remember that this is a minor product, okay? And we have to assume that if we produce the minor product and the major product, we can separate them apart from each other. Okay, so now what I want to do is add HCl. And again, we have to recognize here that when we add HCl, the majority of the time, when we break the double bond, the hydrogen will go to the carbon with the most hydrogens, and the chlorine will go to the carbon with the least hydrogens the majority of the time. But we want the chlorine on the first one, so we're going to get the minor product as the one that we want. Now, this is the reaction scheme that we were asked to do. Include, explain how you might convert. So I need to explain this as well as drawing it. So to a sample 2-chlorobutane, I added potassium hydroxide alcohol heated. I collected the minor product, and then to the sample of this minor product, I added HCl and heated and collected the minor product again. Now be aware here that when we create the collect the minor product is always less than 50% of what I started with. So the first amount here, so if I started with 100% of this, I've got less than 50% of this, and then less than 50% of 50% is less than 25%. So actually in the end I'm going to get not much of what I wanted. And that's one of the problems with very long reaction schemes, is actually the yield or the amount of product produced from what I originally started with can be quite small, especially if I have to go through these reactions where it is the minor product that I want. Okay, and this is the next question I had here. Discuss the expected yield. So as I said here, if we notice that each of these reactions produce less than 50%, then overall we're going to have 50% of 50%, which is less than 25%. Isn't great if I wanted to collect the product. And that's how we might use elimination and addition reactions to move the position of the substituent on an organic molecule. Hey, thanks for watching this video. Hopefully this has made you more confident with your chemistry. Don't forget to like, subscribe, or leave a comment about anything that you want to with this video or any questions you have. I'll see you later.